and welcome to Dundee Science Center. I hope you guys all enjoyed Space Week during our home learning program this year. We are going to talk a little bit today about the UK in space, so what we're currently doing in space through this program called Destination Space. Now, first question I want to ask is, why do we go to space? What are some reasons that we go to space? There's lots of different answers you can have for this. Just some of those are to explore space, right? We want to explore what's out there, because we've never been to everywhere in space, so we want to figure out what else is out there. We want to understand how the universe works. So there's lots of things that we can't do here on Earth because of either gravity or different restrictions that we have here on Earth, and doing some experiments in space can actually help us to understand how the universe works, which is super exciting. To search for life elsewhere. So we want to know, does life exist anywhere else? Or are we the only ones out there? We don't know. And we also go to space to look back at the Earth and learn more about the Earth and where we live. Because some things you actually can't do from Earth because we're already on it. Okay? So in order to get to space, we need to take a rocket. Now, this rocket here is a Soyuz rocket. This is the kind of rocket that takes astronauts to space currently. And in this rocket, where do you think the astronauts sit? Do you think they sit down here where the fire is? Yeah, probably not. No, that wouldn't be good. What about right here in the middle? Nope, they don't sit there. They actually sit way up here at the very top, up in the nose cone area. And the reason for that is because when our rocket takes off, it actually breaks apart when it gets into space. So these boosters down here help it to propel up into space first, and then once it gets up into space and all of this fuel is used up, it actually breaks off to make the rocket a little bit lighter so it doesn't need as much fuel to keep going. And then this part will have its own boosters, which will fire off, and it'll keep the rocket going. And then, once that gets used up, it actually breaks off. And just this very top part here is actually what keeps going through space. And so the rest of it actually breaks off and falls back to Earth. Now, what makes a rocket go? What's coming out the bottom of this rocket here? What's pushing it up into the air? Fire, right? Absolutely, there's fire that pushes that rocket up into the air and up into space. And to make a fire, we need three things. We call this our fire triangle. Can you think of one of them? One of them is fuel. Fuel can be anything. So I'm not just talking about a rocket fire. I'm talking about any kind of fire. So this could be wood. This could be a gas of some sort. This could be coal. Anything that we burn is the fuel. So it needs a fuel, something to burn. We also need oxygen. The stuff that we breathe is also what fires need to keep going as well. And the last thing is we need heat. We need a source of ignition, something that's actually giving energy to burn. Okay? So we need these three things. This is called our fire triangle. And in just a second, we are going to do a quick demonstration of how this works and just how the rocket uses the fire to get up into space.
So here we have a water jug that has some fuel in it. The fuel is isopropyl alcohol. It's not the same kind of alcohols as alcoholic beverages, so don't drink this. We have some oxygen in the bottle, and we are adding some heat with the splint. And as you can see, the fuel is catching fire. What do you see coming out the top?
All right, so in that video, we could see coming out the top of that bottle, that whoosh bottle, we saw some flames that were jetting out the top, right? They were pushing out. The reason why is because inside of that bottle, the heat actually sped up all of the molecules that were inside the bottle, all the air molecules that were inside of that bottle, and because of that they were trying to spread out very, very fast. And when they tried to spread out, the only place to go out was through the spout at the top. Now, in a rocket, it's upside down. So instead of having the spout at the top, the spout's at the bottom, which means that inside the rocket, all of that heat is building up, and it's got to go somewhere. And so it's going to force itself down through the nozzle, and when it forces itself down, it pushes down with so much force that it actually pushes the rocket up into the air. And that's the only thing that's pushing that rocket up into the air. There's no extra turbines, there's no extra engines, nothing. It is just the force of that hot gas pushing down that's forcing that rocket straight up into the air. All right, so we've got our rocket, right? We want to launch our rocket. But we need to figure out where we're going to launch. We can't just launch a rocket anywhere, right? We can't just go out into the garden and decide we're going to launch a rocket. That's not safe, right? So we have to figure out a good place to launch from. Now, if you look at this map here, this is a map of some of the locations of launch sites around the world. And if you notice, a lot of them are in kind of similar types of areas. So if you look here, a lot of them happen kind of in this general area, right? Kind of in the middle section, near the equator. They happen near water, or they're located, I should say, near water, most of them. There are some that are not, but that's because they're in remote areas. There aren't a lot of people in those areas, okay? And a lot of them, if they are not in this central area here, they're either really, really far south or really, really far north. And that's because there are different kinds of orbits, which we'll talk about in just a little bit. So, something really cool is that here in the UK, we are looking to build our own spaceports, because right now we don't have anywhere to launch our own rockets. In fact, we don't really launch our own rockets, but we are really good at building satellites. And we really want to get those satellites up from the UK. So in order to do that, we need to build our own spaceports. And right now, we actually have some spaceports that are in the works that we're actually going to be building in the next few years. And they are located currently, or the potential sites are located, a lot of them over here on the west coast, down south right here, and we also have quite a few up north because they're in quite remote areas. So currently, we have Newquay Airport, which is, or Newquay Spaceport, I should say, I'm sorry, down here in Newquay, in Cornwall. We have Snowdonia is actually planning on building a spaceport as well. Prestwick, Glasgow Prestwick is planning on building, and Sutherland up here in the Highlands is also planning to build. Those are the four that are pretty much there in the works to build right now. There are other locations that are possible. So we've got one in the Shetland Islands, we've got one in Orkney, and one over here in, I don't remember which one this one is. This one is Campbelltown. Okay, so we've got some other places that are looking to build, but they haven't necessarily started the plans yet, or they haven't gotten funding for it just yet. But we do have different kinds of launches that are going to happen. So if you notice, these ones here with little airplanes, these airplane ones mean that those rockets aren't going to launch vertically. They're not going to launch like the launches we just saw. Okay, they're actually going to be taking like airplanes up into the higher atmosphere, the upper atmosphere, and then those rockets are actually going to be released from the airplanes up into space. Okay? Whereas these ones here, these ones that are further north, where there are less people, where they are right on the water there, those ones are actually going to do the vertical launches that we've just talked about. Most of these are just going to be launching satellites. However, there are a couple, like this one down here. Virgin Galactic is actually looking to start some space tourism, which means they're going to take people up in these airplanes. The rocket is then going to, or I'm sorry, the plane is actually going to take them up just to the edge of space and bring them back down again. And so those will be some of the first space tourism opportunities that will be available to normal people here in the UK. So when we get our satellites up into space, a lot of them will be looking out, right? They're going to be looking out at the solar system and at space, but a lot of them are actually turning back to look back at Earth. And we use these satellites for a lot of different kind of daily uses. So maps, if you've ever used a map app or a sat nav, you're actually using a satellite because they help to build up the maps of the area, but they're also used in triangulation, which then tells you your location in that area. We're also using them to observe changes here on Earth. So that's things like climate change. So we can observe the changing of the different ocean currents, the temperatures of the ocean currents and things like that. But we can also use them to investigate some agricultural needs. So things like crop health. Because when we look up here, okay, this is an infrared image of some crop health issues, okay? And what that does is actually it uses an infrared camera on that satellite. It looks back down at crops, and we can tell how healthy the crops are, because a healthy crop will actually reflect a lot of infrared light back up into the atmosphere. But unhealthy crops will actually absorb a lot of that infrared light. So if we find areas where a lot of that light is being absorbed, we can then target those areas and try to mitigate their health, try to make them healthier so that our agriculture can flourish, okay? Our agricultural economy can flourish. Another thing that we can use it for is monitoring transportation. Now, what this means lots of different things. So if you've ever used a map app and it's told you how much traffic there is, right? That's one way of using that. But also another way of using that is to track where ships are moving. So in this map here, you can kind of see all of these bright spots are where ships are. It locates those ships because ships have to have a tracking signal on them in order to be found, right? They're there for safety, to make sure that they don't get lost. But we can also use them in case those ships are actually doing things like human trafficking. So what it can do is it can actually track if a ship is in an area where it's not supposed to be. We can see that using the satellites. Well, also, sometimes if people are doing naughty things, they can sometimes turn off those tracking apps or those tracking signals. And if their ship goes off the radar and then comes back up in a different place, we can then be like, where has that ship been? And we can then start to investigate maybe what are some of the reasons why that ship may have gone missing for a little bit. Another way we can use it is we can actually use it for areas that are very hard to reach in industries, things like building and things like that, or even deforestation. We can use, instead of having to go to these hard to reach places, we can actually use the satellites to investigate are the buildings being built that we've funded. We can check in places, in rural places, if we have funded for a school to be built, we can see, has the school been built? Great, we can see it from space, great. We can check and see, like especially in South America where there's lots of rainforests, we can check and make sure that the rainforests aren't being cleared too quickly and that they're actually being replenished and replanted as well. So looking back at Earth with satellites from space is actually just as important as going out into space and looking away from Earth and looking out into space. Alright, so we're talking about sending up satellites, but we also send people up into space as well. Currently, the only place where we can send people to stay for extended periods of time is the International Space Station. The International Space Station orbits the Earth, and it usually always has 3 or 6 people on it. However, recently we also did just send 2 people up, SpaceX sent 2 people up, so there were actually 5 people instead of 6. But normally there's either 3 or 6 people on the International Space Station at any given time. But there are plans to build something called a space gateway, which would look, this is a proposed plan, this isn't exactly what it will look like, but this is a proposed plan of what the space gateway will look like, which is going to be another space station we can send people. But instead of orbiting the Earth, this one will actually orbit the moon. So what this will actually be like a launching pad for exploration on the moon, or on Mars, or even further afield, further out into space. This will be kind of like a waypoint, a stopping point before people go on to their next stage of their journey. All right, so we've sent lots of people to space, but actually most of the missions that we've sent didn't send any people to space at all. Most of the missions that we've actually sent into space have just been robots. We send lots of robots to space. And this picture here it's kind of hard to see, I know that, but that's kind of the point. If you look at this, every single different colored line is a different mission that we have sent from Earth to other places in the solar system, and even beyond the solar system. You can see, this is the moon. We've sent a lot of missions to the moon. A lot of them, okay? We've also sent quite a few missions to Venus, quite a few missions to Mars, and we've had a few that have gone to Mercury and the Sun, and you can see there's also a few that have gone to all the other outer planets in the solar system. And actually down here, if you look at this graphic down here, this is the solar system here. That's kind of the end of our solar system. And then actually we've got a couple of missions that have made it past the solar system. And actually Voyager 1, which is not even on this map because it's so far, it's the first one that has completely left our solar system and is now traveling into interstellar space. And it has been going since 1977, so it's been going for 42 years. And it is still going, and we're actually still getting some data back from it, which is really, really cool. And hopefully in the next 300 years or so, it will actually reach the edge of the Oort cloud, which is super exciting. So a lot of the missions that we send don't even involve people. In fact, our next mission that we're looking, or one of our next missions I should say, that we're looking to send is something called the Webb telescope. And the Webb telescope is going to be a new telescope that kind of replaces, doesn't totally replace, but it kind of replaces the Hubble telescope. Alright, so the Webb telescope is a telescope that's kind of been in the works for quite a long time actually. It's supposed to launch in October of 2021, and it's got 4 different kind of instruments on it. The one that we're really the most excited about is called Miri, the mid-infrared instrument. And the reason why is it's going to help us see through things that we're not normally able to see using visible light or other spectrums of light. So what we have here, this is the Eagle Nebula, and this is a visible light photograph taken with the Hubble Space Telescope. And it's really pretty, right? There's lots of pretty colors, although to be honest, these colors you wouldn't actually see in real life. These colors have been added later to kind of denote different kinds of gases and things like that. But it's really pretty, right? It's a nice picture. We know that inside of nebulas, stars are being born. We call them star nurseries sometimes. Problem is, because these clouds can be so dense, we actually don't really know how those clouds are forming. We can guess. We have an idea of how it's happening, but we don't actually know for sure. This is a picture of what it might look like in infrared. And so this is actually an infrared picture, but it's not the clearest picture. But it is an idea of what is happening inside that cloud. The infrared light on the Miri instrument will be able to see through these nebulas and be able to nebulae, and tell us exactly what's happening inside of them, so we can actually investigate how galaxies and stars are born for the first time in really good definition. Now, how is it going to do that? Just like this. Now, I need a volunteer, so I'm going to ask my friend Emily to come on up and help us out. So I'm going to place this here if you want to go ahead and grab that. All right, so my friend Emily here is going to help us explain how we're going to be able to see through these nebulae and see what's happening inside of them. So if you look at Emily just now, you can see her legs, obviously, perfectly fine. Now, Emily, would you please step inside of the bin bag? Looking at Emily just now, can we see her legs inside the bin bag? No. We see the bin bag, but we can't see inside the bin bag because it's black, right? It's opaque. We can't see through that. However, if I use my infrared camera here, and I'm going to swap views. Now, if we take a look at Emily's legs here, now all of a sudden, we can actually see her legs. Emily, can you give us a little dance? A little jig. Woohoo! Very good. We can actually see Emily's legs, and that's not just the heat from her legs that's warming up the bag. That's actually legs. You can actually see like the details of her feet. You can actually see where her shoes kind of end, where her ankles start, right? You can see that her calves are a little bit warmer, right? Absolutely. So you can actually even see the wrinkles of her knees in her trousers there. So we can actually see her legs, and the reason why is because the infrared light that this camera is actually reading or registering, there we go, is passing through, or I should say the infrared light from her legs is passing through the bin bag, and this camera is able to pick up that infrared light, whereas the visible light coming from her legs is not able to pass through that bin bag, and so we can't see it with our normal eyes because our normal eyes only see invisible light. Very good. Thank you very much, Emily. Let's give Emily a big round of applause. Yay! Another way to explain this too is down here I have a kind of an image of this, actually this is a different nebula, and if you look at it closely you can see we've got some stars that are lit up. Now, I'm going to tell you a secret. All of the stars here, well not all of the stars, several of the stars here are actually lit up, but you can't see all of them because some of them are only lit up in infrared. They're hidden in the clouds, we can't see them because their infrared light can't pass through them. However, when I take my camera, again, down here, if we look down in the corner, you can see there are quite a few stars that are showing up. Those bright yellow spots there that you see are actually stars that are lit up. But we can only see them with the infrared camera because their light can't, their visible light cannot pass through the clouds. So what we have here is, this is an example of a wavelength. So this could be something like visible light, and say this is some visible light that was emitted just after the Big Bang. Because the universe is constantly expanding, this would also be constantly expanding as well, and at one point it will finally reach infrared radiation length rather than visible length, which means that Webb can actually detect this infrared radiation. We can actually dial this back so that we can see what the infrared light would have looked like when it was visible light, which can then tell us what the universe looked like just after the Big Bang. Alright, so Webb is going to have lots of really interesting jobs for us, and we're going to get lots of new information from it using these different instruments on board. And Miri is not only just going to be looking at how stars and planetary formations are formed, and galaxies as well, but it's also going to help us to learn what the Big Bang looked like and what the universe looked like just after the Big Bang. Okay? Well, the way it's going to do this is it's actually going to be looking so far out into space, okay, that it'll be picking up traces of infrared light that have been stretched and were originally emitted as visible light. Right? Sounds weird, right? It almost sounds like we're looking back in time. And in a way we kind of are. We're not turning back time, okay? It's not a time machine. But what it's doing is it's actually taking light that was visible, and because the universe is constantly expanding and stretching isn't exactly the right word, but it's expanding, right? It's taking the light and it's actually lengthening the wavelengths of the light. And as wavelengths get longer, they start to change the kind of light or energy, electromagnetic energy that is, radiation, excuse me, that is being emitted. So what we're doing is we're taking visible light, which has this wavelength here, okay, and as it's getting stretched or lengthened, it's now getting to a point, the wavelengths are getting to a point where our eyes cannot see them anymore, and it's becoming infrared light. Okay, and then as it gets stretched, it gets further and further and further. So if we can take that and we can account for what we call redshift, we can actually then take that light back to what it would have looked like just after it was emitted, which would be sometime right around the Big Bang, which is super cool. So we'll start to be able to see just how the universe was formed. Okay, so not only are we sending the Webb telescope up, but also there's a mission called ExoMars that started back in 2016 and is continuing in 2022. And in 2016 we sent up something called the Trace Gas Orbiter, and the Trace Gas Orbiter was sent to Mars. And an orbiter is something that goes around the planet. It doesn't land on the planet. And what it was doing was looking for trace gases. Now, trace gases are very, very tiny amounts of gas in the atmosphere. And the things we were looking for were things like methane, water vapor, nitrogen oxides, and acetylene, because those can sometimes be signs of life. Not always. Sometimes geological processes, or things that are like rock formations, they can sometimes release these gases as well. But a lot of times, especially here on Earth, they can be signs of life. Now, do you think there is water vapor on Mars? Do you think there's water on Mars? Where do you think it is? Think it's at the top? There? Or at the bottom? And these ice caps? there's a tiny, tiny amount of water in these ice caps, but actually these ice caps are mostly made up of carbon dioxide. It's more like dry ice. The water that we found using this mission is actually not on the surface of Mars. It's under the surface, which means if there's water under the surface, there could also potentially be life under the surface. And that's where our next part of the mission comes in. Actually it says 2020, it's now 2022. The Rosalind Franklin rover is going to be going up. It's going to land on Mars. This one actually will land, and it is a rover, so it will move around the surface, and it will have a 2-meter drill right on the front here, and it's going to drill 2 meters down into the surface. It's going to pull up samples of soil, and it'll be able to sort through and do experiments to look for different chemical processes that might lead us to believe that either there is life on Mars, there was life on Mars, or there could be life on Mars. So it's really exciting. In the next 2 years or so, we should start to be able to answer some of these questions about, is there life out in Mars or out in the rest of the solar system? So thank you guys for watching today. If you have any questions, please post them below. We will do our best to answer any questions that you have. And stay tuned and definitely keep your ears open for some of these new projects that are coming along. Listen out for the Webb Telescope and listen out for the Rosalind Franklin rover being launched. And also keep your eyes open for spaceports because they're going to need lots of jobs. So definitely apply. Awesome. See you guys later. Bye.